Wait, what? The Big Bang Theory is wrong? What about our existence? Where do we come from? As JWST proves, the Big Bang Theory is wrong. Many questions begin to emerge, but don't worry, you are on the future space, where we reveal every single secret, so stay tuned. For more than 50 years, we have had undeniable scientific evidence that the hot Big Bang was the beginning of the universe as we know it. The universe used to be smaller, hotter, denser, and more uniform, but now it's expanding, cooling, and filled with clumps like planets, stars, and galaxies. The known universe is expanding, rarefying, and cooling, and the laws of physics allow us to extrapolate both backward and forward. In mathematics, how far back can we extrapolate from this? It can be tempting to push the boundaries all the way back to infinitely small dimensions. Singularities are defined as infinite densities and infinite temperatures. The Big Bang was the name given to the physical concept of a single beginning for all of space, time, and the cosmos, though we have discovered that when we look closely enough, the world actually told a different story. Here's how we know the universe didn't begin with the Big Bang. Like most scientific tales, Albert Einstein's general theory of relativity has been put to several scientific tests, resulting in some of the most severe limitations ever attained by mankind. The origin of the Big Bang can be traced back to theoretical and experimental or observational fields. An innovative gravity theory that seeks to replace Newton's concept of universal gravitation. Einstein's general theory was introduced in 1915, despite the fact that Einstein's theory was much more involved and difficult to understand. The initial precise answers were quickly discovered. In 1916, Carl Schwarzschild solved his definition of a non-rotating black hole as a point-like mass. Willem de Sitter discovered the solution for an empty universe with a cosmological constant, which describes an exponentially expanding cosmos in 1917. The Reisner Nordstrom solution, discovered independently by 4 physicists between 1916 and 1921, defined the space-time for a charged spherically symmetrical mass. In 1921, Edward Kassner discovered a solution depicting a world devoid of matter and radiation that is anisotropically different in all directions. Alexander Friedmann discovered the answer to the question of how to create an isotropic and homogeneous world in which all forms of energy, including matter and radiation, are present in 1922 for 2 reasons. The last one was particularly intriguing because it seemed to describe the largest scales of our universe, where objects appear to be similar in general everywhere and in all directions. Furthermore, if the Friedmann equations, the governing equations for this solution, were solved, you would discover that the world it depicts cannot be static and must instead either expand or contract. This latter truth was acknowledged by many people, including Einstein, but it was not given much weight until observable evidence began to back it up. Vesto Slipher, an astronomer, began observing nebulae in the 1910s and discovered that they were moving very quickly, much faster than any other object in our galaxy. Furthermore, the majority of them were moving away from us, with fainter, smaller nebulae appearing to move faster in general. The distances to individual stars in these nebulae were then calculated by Edwin Hubble in the 1920s. As Lemaitre, Robertson, Hubble, and others quickly realized, Georges Lemaitre was the first to recognize this in 1927. After discovering the expansion, he projected backward, assuming, as any capable mathematician would, that you could go as far back as you wanted to what he called the primeval atom. He realized that everything we see around us came from an earlier time when the universe was just a hot, dense, expanding collection of matter and radiation. We can see that the universe has grown more developed since then. As we travel further back in space, we travel further back in time. As a result, objects from that era should be more recent, less gravitationally clustered, smaller, composed of fewer heavy components, and have less developed structures. The rate of the universe's initial expansion, as well as the total amount of matter and energy present, are all observed to be perfectly balanced. If the Big Bang was caused by a singularity, we can say that the universe was created in this manner, or as Lady Gaga put it, initial conditions. We don't see any magnetic monopoles, which would be predicted to exist in a universe with arbitrarily high temperatures. Even though the universe is observed to have identical temperatures everywhere with an accuracy of 99.99%, different temperatures would be predicted in areas that are casually detached from one another, i.e., are facing opposing directions in space. We are always free, despite our observational limitations, to use the beginning conditions as the basis for any explanation and to conclude that something is the way it is because of how the universe came into being. However, as scientists, we are always much more interested if we can identify a cause for the characteristics we observe. That and much more. That is precisely what cosmic inflation offers us. Yes, you can extend the hot Big Bang back to an incredibly early, incredibly hot, incredibly dense, incredibly uniform state, but you must stop before you reach the singularity. According to inflation, there must be a way to configure the universe so that the rate of expansion and the total amount of matter and energy are balanced. The same is true for a universe with constant temperatures throughout. A slightly different point is that in order to prevent high-energy relics from forming, you must first find a way to eliminate any that may already exist while also preventing your universe from becoming too hot. Inflation employs the same method discovered by de Sitter in 1917 to propose a time prior to the hot Big Bang when the universe was dominated by a large cosmological constant, or anything that behaves similarly, by capping the highest temperature that can be attained when inflation ends and the hot Big Bang occurs. This phase flattens the universe, giving it uniform properties everywhere and preventing us from creating new ones. Inflation explains the puzzles that we can effectively solve by stating the starting conditions in the Big Bang. All four predictions that can distinguish between a hot Big Bang without inflation and inflation have been tested with sufficient precision that inflation is 4 for 4 on those four fronts, while the hot Big Bang is 0 for 4. However, if we return to our original concept of the beginning, things begin to become extremely fascinating. An inflationary world cannot be extrapolated back to a singularity, but rather to a universe containing matter and radiation, and the hot Big Bang can only reach microscopic sizes. It will never reach infinite temperatures or densities due to the exponential nature of its expansion. This implies that inflation, rather than necessarily causing a singularity, cannot lead to one on its own. We had to abandon the idea that the universe began to form from a singularity, and that's what the Big Bang was the moment we realized there was an inflationary phase preceding the hot dense and matter and radiation field 1. This new image contradicts the conventional narrative that most of us were taught first, the original theory of the hot Big Bang, which states that the universe erupted from an infinitely hot, dense, and small singularity and has since expanded and cooled while being full of matter and radiation, is false. Although we can only extrapolate the picture so far back in time, it is still quite accurate. Second, observations clearly showed that cosmic inflation existed prior to the hot Big Bang. During the early universe's exponential growth phase, before the hot Big Bang, any prior elements of the universe were figuratively inflated away. When inflation ended, the cosmos overheated to an arbitrary high temperature, giving rise to the hot, dense, and expanding universe that eventually evolved into the one we live in today. Finally, and perhaps most importantly, we no longer have any understanding or confidence in how the universe originated, or whether it did by definition. Inflation erases all knowledge that existed prior to the final few seconds before it ended, resulting in our fiery Big Bang. It could have occurred prior to inflation, prior to some other non-singular phase, or prior to inflation for all eternity. We have no choice but to accept our ignorance until we figure out how to extract more knowledge from our universe than appears to be possible right now. And that's it for today, guys. We sincerely hope you enjoyed the video. If so, please click on the like button and share it with your friends and family. If you have any questions or comments, please share them with us in the comment space below. Also, don't forget to subscribe to our YouTube channel to see even more of our incredible videos. You can also check out our other videos that have been specially selected for you. We'll catch up in the next video.